Okay, so this is the supplemental notes for lesson 11.8, analyzing residuals. So when we're analyzing residuals, a residual is the difference between the observed y value from a given data point and the predicted y value from the line of best fit. A residual is positive if the data point is above the line of best fit, and a residual is negative if the data point is below the line of best fit. And the residual is 0 if the data point is on the line of best fit. A vertical line between a point and the line of best fit represents the distance of the point from the line. This vertical line is called the magnitude. When we find this magnitude, we find the absolute value of the residual. Okay, so here it says the predicted values were computed using the line of best fit y equals 3.2x plus 2. What are the residual values needed to complete the chart? Okay, so how we find a residual is taking the given value and subtracting the predicted value. So for A, our given value is 6.1 and our predictive value is 5.2. So 6.1 minus 5.2 is 0.9. Okay, for B, our given value is 7.4 and our predictive value is 8.4, and 7.4 minus 8.4 is negative 1. For C, our given value is 11. Our predicted value is 11.6. And 11 minus 11.6 is negative 0.6. And for D, we have 15 is our given value. Our predictive value is 14.8. So our residual value is 0.2. So the residuals are these values right here. They are our given minus our predicted. If it was asking for the magnitude, we would find the absolute value of these, so there would not be any negatives. All right, consider the plot was created from the residual of a line of best fit for a set of data. Does the residual plot show that the line of best fit is appropriate for the data? All right, so this is going to be no, because it follows a pattern. If it follows a pattern, it is not a good residual. We've talked about residuals in the past, and residuals do not follow a pattern. Because this basically is linear, it would be no, and it's because it follows a pattern. So it would be C. All right. Points and their residual values are shown in the table. Which point is furthest from the line of best fit? All right, so this has to do with the magnitude. So we're looking at the absolute value of our residuals and what is the largest absolute value. So our largest absolute value here is this value right here. Because yes, it is negative 1.1, which technically is the smallest value, but because we're looking at the magnitude or the absolute values of these values, so this would be a positive 1.1, which is greater than a positive 1.02. So that point is 3, 6.2. What does a residual value of negative 4.5 mean in the reference of the line of best fit? Okay, A says the data point is 4.5 units above the line of best fit. No, because it's negative. The data point 4.5 units below the data point, and that is a true statement. It is 4.5 below. Okay. Which statement describes a residual plot for a line of best fit that is a good model for a scattered plot? Check all that apply. There are about the same number of points above the x-axis as below. That should have been true. That should have been an option. So that should have been an A. We'll make this a B, C, D, E, and F. All right, so A is true. All right, the points are, because it needs about the same above and below, the points are randomly scattered with no clear pattern. That is a true statement. The points lie on a line. No. The points lie on a curve. No. The number of points is equal to those in the scattered plot. Yes. The y coordinate of the points are the same as the points in the scatter plot. No. All right, so in order for it to be a good residual plot, there needs to be the same number of points above and below the x-axis. The points are randomly scattered with no clear pattern, and the number of points is equal to those in the scattered plot. All right, computing residuals. Find the predicted value by entering the x value from the table into the equation for the line of best fit. Compute the residual by subtracting the observed value by the predicted value. All right, so the line of best fit to model the data in the table is y equals 5.2x minus 0.4. What is the residual for 5? Okay, so what we are going to do is we're going to substitute 5 into our formula that they gave us, and that will give us our predicted value. So I'm going to take y equals, we're going to take 5.2, and instead of an x, we're going to substitute in 5 minus 0.4. So we're going to take 5.2 times 5. We're going to get 26 minus 4, or 0.4. And we're going to get 25.6. So that is going to be our predicted value. Our observed value for 5 is 24. So I'm going to take 24 and I'm going to subtract 25.6. And I'm going to get negative 1.6. So that is going to be my residual value. Residual plots. Make a table of the ordered pair. Find predicted values by entering the x values from the table into the equation for the line of best fit. Compute the residuals by subtracting the observed y values by the predicted y values. Plot residual points on the graph. Okay, a scatter plot consists of 1, 4, 2, 3.3, 3, 3.8, 4, 2.6, and 5, 2.7. The line of best fit used to model the data is y equals negative 0.33x plus 4.27. Which residual plot is correct? All right, so we're going to make a table of values. So I'm going to have my x, my y, And then this is going to be my predicted, and then my residual. Our x starts with 1, 2, 3, 4, 5. The actual points that are y are 4, 3.3, 3.8, 2.6, and 2.7. I'm going to substitute these x values into my formula and solve for y. That's going to give me my predicted value. So for example, I would take y equals negative 0.33 times 1 plus 4.27. And I am going to get 3.94. So my predicted value is 3.94. So then I'm going to take 4 minus 3.94, and I'm going to get 0.06. Okay, so at 1, we're going to be at 0.06. So all of them, this one looks negative. So those two look negative. So C and D look negative. So now we're going to plug in 2. So I'm going to do the same thing, plugging in 2. So y equals negative 0.33 times 2 plus 4.27 equals 3.61. And I am going to, that's going to be 3.61. Then we're going to take 3.3 minus 3.61, and we're going to get negative 0.31. Okay, well, these both look like negative 0.31. So now let's try 3. Y equals negative 0.33 times 3 plus 4.27 equals 3.28. 3.28. 3.8 minus 3.28 is 0.52, so about a half. So B is about on a half. This one's above the half, so I'm going to say it is B. We can continue our table. If I were to input the values, I get 2.95, which would give me a negative 0.35. We'll just make sure that matches. Yep. And then we'll put in 2.26 for this one. 2.62, I mean, and we'll get 0.08, which that looks like that's 0.08. So B is the correct answer. Analyzing residual plots. So, a good model. If the line of best fit is a good model for the scatter plot, then the residual plot is going to appear random. If the plots on my residual plots are close to the x-axis, this means that the data on the scattered plots are close to the line of best fit. For a bad model, if a line of best fit for a scattered plot is not good for the model, the scattered plot is going to have a pattern. The pattern can either be linear, so like a line, or curved pattern. If we have a curved pattern in our residual plot, this means that we have a nonlinear relationship in our original scattered plot. All right, so this is a good residual because it's random above and below, and there's about the same amount above and below. This is not a good residual because it has a curved shape, like a parabola. If you have any questions on this lesson, feel free to ask.